The mass of an evacuated 250 ml flask is 105.2 grams. The mass of the flask filled with 415 torr of an unknown gas at 30 degrees Celsius is 105.7 grams. Calculate the molar mass of the unknown gas. So if you use the ideal gas equation, you will arrive at the formula for the molar mass of the gas. So the formula is molar mass, capital M, is equal to mRT over PV. So if you want to see how this formula is derived from the ideal gas equation, you can check the description box below. Okay, so what is M in the formula? M is the mass of the gas. So M is the mass of the gas. So how do we compute that? So the problem says you have an evacuated flask that is 105.2 grams. When you say evacuated flask, that means a flask that contains nothing. So not even gas particles, not even air. So that's an empty flask and its mass is 105.2 grams. When you fill the empty flask with unknown gas, its mass becomes 105.7 grams. So in order to compute the mass of the gas, that is just the mass of the flask with the gas, which is 105.7 grams, minus the mass of the flask without the gas, or 105.2 grams. And that is equal to 0.5 grams. So the mass of the gas is 0.5 grams. R is the gas constant. So we know that the value of R is 0.0821 liter atmosphere per mole Kelvin. T is the temperature in Kelvin. So according to the problem, the temperature is 30 degrees Celsius. We need to convert that to Kelvin. So in order to do that, you just add 273.15 and that is equal to 303.15 Kelvin. P is the pressure and the unit must be in ATM. So we need to convert the given 415 torr to ATM. So you have 415 torr. And we know that 1 ATM contains 760 torr. So torr will cancel and the pressure is 0.546 ATM. And V, of course, is volume. And the unit must be in liters. So the given volume is 250 ml. We need to convert that into liters. So 250 ml, we know that 1 liter contains 1000 ml. So ml would cancel and that is equal to 0.250 liters. Now that we have every values needed for the calculation, we can calculate now for the molar mass. Molar mass again is M, that's 0.5, R, 0.0821 liter atmosphere per mole Kelvin, T is 303.15 Kelvin divided by P, pressure, is 0.546 atm and volume is 0.250 liters. So if you cancel the units, liter will cancel, atm would cancel, Kelvin would cancel. We are left with grams per mole, which is the unit for molar mass. So if we solve the molar mass, this is equal to 91.2 grams per mole. And that is the answer to this question.